Okay, so I am assuming that everyone can open CASA and load the data and see the list stops, and everyone have done it. And I guess this document is also shared with all of you, and you can just open that thing. So this part is already done. Everyone understand what is in the data, like what is the calibrator, what is the phase calibrator and all, right? Yeah, okay. So how many have you found out the bad antenna? Anyone? Okay, so you guys have a list of bad antennas, right? But not everyone. So then, okay, let me then plot again and find out the bad antennas. And so I'm giving field 0. 0 is basically your flux calibrator, or probably let's plot all the calibrator. But go to the axis, plot time, amplitude is data, in page, iteration over antenna, right? And then at display, you colorize by field, okay? Yeah, one frequency. So we know that there is only one spectral window. Unlike VLA, we have this one spectral window and let's say one central frequency, 128. Right, so you guys have seen this plot yesterday. We have flux calibrator, which is black, then phase calibrator, which is pink, and then orange is basically target, right? And you just need to iterate over all the antennas. So this antenna is bad, right? So if you guys have found this antenna bad, that is good. So you can clearly see that for a large amount of time, that antenna is bad. Only the last scan is good. So this is C08. So this antenna is also bad, right? S06, because you see that the amplitude of all the targets, not all the targets, all the fields are same, and it is very low, like 0.15. Even before calibration, it is very low. So it is definitely bad. So this is another one is S06. Okay, this antenna is also bad. Like it was working in the beginning, and up to this point it was working, but then it is not. So we are flagging this also, W03. Yeah, that is the last one, right? Okay. So right now then we have these antennas which are bad. Have you guys find all these things or no? Right? So this is matching with your findings. Okay. So I think the first task is basically flagging all these antenna. So that task is also written here in the document. Okay, we'll plot these branches later on, but let's first do the flagging. So this is called flag data task, okay? So the way we load the task is like this. So you write default flag data. So flag data is the name of the task, which will basically allow you to flag your data in various way. Default, I am plot using that because it will just take the default value in the beginning. It will not load the previous run. Note that if you run in Casa, you can load the previous run also. Like if you have already run some command, you can load the previous run by some command, which I'll show later. But it is always better to do this default task. Otherwise, it will load from your cache memory. Okay. So run the default flag data and then do INP. INP is basically show you all the options, right? Like what are the options uh, in that particular task are available. So initially the V's is basically your data name. So V is equals to, and you need to put it within that column, right? And that another advantage is for every task there is a guidelines just right next to that thing. So these are all the guidelines how to put that thing in that options. And there is, if there is a colon, you have to provide this within that column, right? So these are the basic options you have within the flag data task. Okay, so everyone is up to this point. Like what I've done, just basically put the V's, which is actually my MS file name, within that colon, and I choose an option which is mode, basically manual. So I am saying that manually flagging those antennas. There are three antennas which we found: C08, F06, and W03. Are you guys already? Huh? Oh, scroll down. Okay. Like this is a basic Python. If you guys know Python, this is like how you do in the Python, right? You just provide the name and they will just flag it for you. So flag data task will flag these antennas for you. Uh, Mode is actually manual. So we are basically manually flagging some bad antennas here. Are you guys already at this point or no? Yeah, yeah. Are you guys at this level? Everyone? Who is not at this level? Okay, so everyone is following. So okay, okay. So the next way, Okay, so if you are already at this stage, just write go and put enter. It will just basically flag the data for you. Oh, add data must be a string. Hmm?
The document type is proper format. You can check.
Yeah, but this should be using the.
No, I think they changed that. I think you need to put and between.
No.
Take the document. Go scroll down.
Yes. Okay, they put the antenna like this without the third bracket. So basically in a string. Okay. Yeah. So it's basically now did the flagging. You can now check with another plot MS task.
Also, after you have added any flags, there will be a separate directory created called ms.flag versions. So you can read into it. Basically, it's tables. You won't manually read it, but this is the flag versions directory is what the flag manager task will access. So you can check it. And also Google is free. So if you have any other errors, you can Google them.
Okay, so I'm plotting it in a different way. This is also to look whether it is flagging or not. You flag 3 antennas, right? Here I'm plotting time. Y-axis is all my antennas, and for a given antenna to assess time. You can clearly see that you flag this antenna and the S06 like there and on top of there. So it is basically showing that it is already flagged. You can look into in a different way also, like similar to what you did before. So it is time, and then this is amplitude. Colorized by field. So now if I go to C08 here and plot it, you see that all the data has been flagged. So I guess you guys are able to flag the antennas, right? You are not. Okay, so you need to mention this without the bracket. It should be a string there. Okay. Uh, Cannot be opened or it's showing that you have already flagged it. Task flag data complete. Is it something different? Where are you working? Yeah. Like, do you need sudo to do that? Okay. It's all automatically coming in bracket. Okay. Your image is already here, right? Cannot be open for read and write. That's why, like, do you need sudo to? Like, where are you running? This is in the line.
Flag manager, and there is an option for list. Use zero variable name, use zero mode.
You can do this thing.
They give you information about the flag.
Please stop. You cannot open the flag data because this is actually writing a flag data column within the image and it is unable to open that thing. This is strange. You are also running in the same cluster. Tarva, he is unable to open that image file like in the flag.
What image?
So we are flagging this thing and this error seems like she needs a sudo access, right? I don't know why she cannot open, read or write.
You are writing the antennas wrong.
Yeah, that's right. Like just one first comma and run.
Yeah, she did that thing. It is coming automatically like this. Which version of Kasa you're using? Yeah, I tried this one only. W03. INP. Do INP. Now let's say go.
Supply, right?
Yeah. I tried this one only, just.
हाँ ये तो अप्लाई हो चुकी है ना लेकिन वेट
लॉग में देखो
और रीड राइट नहीं हो रहा है.
प्लॉट एमएस में
ओके वो क्लस्टर में रन कर रहा है तो इसका परमिशन नहीं था. ओके. नो जो डेटा फ्लैग नहीं हुआ अभी तक. ये तो आ गया ना. दिस एंटेनास आर ऑलरेडी मेंशन, नॉट बीइंग फ्लैग. I think she needs to run again because there was no write permission.
Oh, there is no right permission.
She's running the cluster machine. Now, I think then if you have the right permission now, just exit and then open Casa again.
Open Casa and then
Yeah. Open Casa. So T gate flag data, T gate, GET gate. So you're basically getting the all the things which is INP. Every time to INP is fine. Now go. Still not. No, no. This is you. No, do this plus 77 minus capital R, then radio CH mod, CH mod minus R before radio minus R plus 77 plus 77. No, your yeah minus R would be later minus capital R minus capital R then radio. It is showing that operation not permitted. You are unable to do this. So that's why she cannot read or write. You are working in this folder, right? Can you do PWD? You put the minus R again. Minus is basically doing all the files within, yeah, within the video. Now, now do this ls minus lrt. Yeah, you should be able to do it. Go to within radio coscon, or then do ls minus lrt. Your exam is it has access. But are you working as a root or no? Try it again. Tget. Go. Yeah, now it's working. I guess it's now do a plot image and check.
Also, if you want to like see whether the flagging is done or not, first of all, obviously, if you plot the flagged part, it won't show. But in the display option, you can change the symbol for flagged data. So if you go here in display, there is flag point symbol. So here you can just click on default and plot again, and it will show up all the flag data as before. But if you put none, then obviously it won't plot the flag data. And so if you don't see anything, that means your data is flagged correctly.
Two plot images close to both. Yeah. So you can just, again do an iteration and you can find which one is being flagged. Oh, you are already in the next step.
Okay.
Oh, is it?
No, that error is because you are copy pasting directly from the document. So
Yeah.
I did
LaTeX
that.
formats the
Oh.
inverted comma wrong.
Yeah. So, have you flagged the antennas? Bad.
No.
So first do this thing.
Just take care if you are like directly copy pasting the instructions from the document, because the quotation marks in the LaTeX formatting of the PDF are not the correct quotation marks how they would appear in your terminal. So that would give you an error. So just take care if you're like copy pasting, put the quotation marks at least by yourself.
Why it's coming within that? Let's try. It must be a string. It is showing that. I'm giving a string, right? Oh, okay. I think I need to give like this. So to check that whether it is flagged or not, you do .ms.
That was hanging.
Where is it? This one, this one. So you see that
Oh,
how to.
that is not happening.
Okay. So it's basically this antenna is being flagged. Well,
You can.
let's close this thing. I can default .ms inp. Okay. So you can fill out all the options. So put this equals to, sorry, equals to, right? And x-axis equals to time, y-axis equals to, y-axis equals to amplitude. So x-axis is time, y-axis is amplitude, and then iteration over antenna. You can do write it here, or you can open it and do it here, because here is hanging. I am plotting it here, and then color. What is the option? Color axis. So I am putting different color for different field, and now let's go. So it's still hanging. How to close this thing? Don't force quit. Let's another way, like I can reduce this thing. Ms inp etc. I can do one thing. SPW plot a single channel. 120 number of channels. 0 is your spectral window ID, and 120th channel I am just plotting. That's a single channel. This should take less RAM. Let's see. So now you can change this thing and check whether that antenna has been flagged or not. Iteration over antenna, then go to data. Yeah. So it is now coming 300. Now just change. It is flat. It is. So it's flat. Done. So let's go to the next step. I guess everyone flagged the bad antennas, right? Okay.
Because from the starting, because there is also this bad antenna chunk that I need to like show. What they do is basically they're putting this yellow here, right? So to make this kind of part bad. So you can flag channels as well.
Yeah.
And then like
Okay. So let's do plot the like follow these documents and let's plot this thing. Like this is a band shape. Okay. So go to T-gate plot ms INP and go. So basically first choose the file which you have, right? And here you see that this is a plot of amplitude versus channel. So this is the how the amplitude of your one field, the field number is 1 here, is changing as a function of channel. This is what we are trying to plot. Field 0.
okay, so put field number 0, put the spectral window as 0, 1 to 256, and the rest is fine. So put
Active. It is, I think, default.
wait. So put field number 0, put the spectral window as channel number 1 to 256. Then in axis you can on x axis you will have to put channel number or channel. On y axis it should be amplitude only. So you can if you have plotted any particular antenna earlier in the pages, so also make that none. So pages axis should be none. The data axis, x axis should be channel, y axis should be amplitude, and you are plotting only the first field, which is your flux calibrator. So this will show your band pass like this. So as you can see, there is this chunk at the end, right? So that is because this is a band 5 observation, but in GMRT, when you are setting up an observation, you can request any specific bandwidth you want. However, not in all bands they can give you the full 400 megahertz bandwidth due to various reasons, which you can ask our esteemed teachers later on. But the point is, they can shift the LO so that the band after a certain amount of channels or this certain frequency will basically be made useless. So the actual usable band is only from like some 196 or 195 to beginning. Okay, so we can actually directly flag out all the channels that come after this point where the band is made useless. Arnab will take you through that.
Yeah. So I guess all of you have plotted this thing, right? Okay. So like as Atharva mentioned that you have the high frequency channels which are bad, we are just basically throwing that out. So again, if you just follow the documents, they already mentioned that how to flag that. So follow this part of the task, which is here. Now go do the T-gate flag data and do INP and let's see what is mentioned here. So you already flagged the antenna, so you don't need to flag it again. So you just do okay. So you are again in the manual mode and you know which channels are bad. You are just throwing away those bad channels, and that is also mentioned in the document. Okay, so it is mentioned that you go to the zero spectral window, you flag the first 5 channels 0 to 5, and you also flag the end channel which is 190 to 255. You just need to do mention this in the spectral window. So 0 is basically your spectral window ID, and you have only one spectral window, as I mentioned before. So 0 is that, and then 0 to 5, right? So 0 to 5 you mention like this, and then there is a semicolon. Okay, like this is the way you need to provide. So if you need to provide two spectral range, you need to provide like this. So 0 to 5 will be like 0th channel to up to 5th channel, and then the next range is 190 to 255. So again, if you do INP, you will find that I mentioned SPW 0, like 0th spectral window, and on that you need to flag the first 5 channels and the last channels, which Atharva also showed that those are bad. Are you guys at this point already? Okay, let's wait for everyone to follow up to this point. Like this is also mentioned in the document. If you just open the document, this range is also mentioned there. So, but don't like while copy pasting, you just need to mention that the code is basically as a Python, not the LaTeX version. Sumit, you also check whether people are doing or not. Go to a separate row and find out whether everyone is. Are you guys able to do it? Okay. She is there. So I hope you guys are already here, and then you just again need to run Go. You can give a reason like why are you flagging as mentioned in the document, but that is up to you. You're done, right? Okay, so then when you mention that, just write Go, and it will basically again flag that thing. Okay. So just to check again, you can do tcat plot ms and Go. So you again choose your ms file. You choose channel and amplitude, right? It is none, and let's plot it.
So, like the band pass we showed earlier, right? So in that band pass, you can see that some part at the end is very like basically dead, so to speak. It's not really dead, but it's basically unusable because if you try to take that part into account for calibration, it won't be able to give you good results. So basically they are nerfing it down, that part of the spectrum, because they cannot give you the full data due to various reasons. You can ask in the Q&A, but the point is you only get some part of the band that is actually usable. And basically you inspect only using like the flux calibrator, because that has a reliable band pass anyway. And you can do this, you can see where the band basically dies down and then like stabilizes at its died down stage. So that part is basically bad. And anyway, for flagging the initial and end few channels of the band for all scans is anyway good, because that will give you better results in calibration. Where the band is dying down, there you won't, there the solutions that it will try to fit for this calibration process won't be as good, or it won't even find any good solutions.
So yeah, if you flag it and then if you replot it, you will find that you already flagged this range. There is no data, and you also flagged few channels in the beginning, right? So your band shape is basically going up, then stay flat, and then going down. You are just flagging that end range. So I hope everyone is up to this point. Can we check this row? Are you guys at this? they are also.
R flag, TF crop, and
No, there is this quack mode, right?
so quack you can explain, right?
Yeah.
So it will like 10 seconds of every
Beginning.
scan, 10 seconds of every
Right.
at the beginning and the end.
So everyone is done, right, up to this point? Everyone is done up to this point, like flagging the spectral window? Or flagging the start few channels and end few channels?
Is there anyone who has not caught up yet up to this point? Anyone?
It seems no.
Okay.
Okay, so next, move on to the next flagging step, which is basically quack mode. So if you go there in your terminal and do default flag data. So default means basically load all the default parameters, okay? Not the previous parameters. If you do it and do an INP, you will see that everything is gone. No previous parameters are mentioned here. So first is basically feats. And the mode right now is quack. Okay, so this mode is basically telling you, like this flagging task is basically for every scan, your dish is moved from one calibrator to another calibrator, right? For every scan or another target. So you are basically flagging the start few second and end few second of that scan by this particular flagging method. Just because it is not stable, right? Your dish is at this location and then it is going to another location to track that source. So initial few second and the end few second will not be that stable. So that's why we are flagging the initial 10 second and end 10 second. So it's basically like this. So you have this calibrator here, and your dish is basically looking into this range, this particular calibrator. So you just move your dish like this, right? You are basically taking that particular one. And then the next scan, you have another source here. Now you just moved your dish along this direction. So while this moving from one to another, you have different scan, but in the beginning and in the end, the data will not be that stable. So that's why we flag like in the beginning 10 second and in the end 10 second by using this quack mode. Okay. So you can clearly see that the mode is quack. So quack interval is how much second you want to flag, which is basically 10 second in our case. Yeah, it is 10 second. Sorry, it should be and the quack mode is beginning. So it is basically BEG for beginning. So you are basically flagging the starting 10 second of every scan. Okay. And your action is basically apply. So you are basically applying that flag to your data.
So just before pushing go, just check all the inputs are according to the document.
Yeah. So if you do INP, you will find that there are only two things. One is quack, which is the mode of operation, and then the quack interval is 10 second, and quack mode is BEG for basically beginning, the short form of beginning. So you're basically flagging the first 10 second of every scan. And you can clearly see that the document is also mentioned here, like what it is doing. So if you are not sure, you can just read that thing here and find out what it is doing. So I hope everyone is at this. Is it? Help दिखा देंगे इसके बाद. Let's see how that is. Are you guys already here? Okay. Not okay. Let's wait. Okay, I'll go slowly. So quack interval is basically seconds. So it is also mentioned that quack n seconds from scan beginning or end. So you are basically flagging 10 seconds. Okay. Like since this is moving, like the dish is moving, it is not stable. So that's why the first 10 seconds we are flagging. Are you in the flag data task? Are you sure? It's not flag data task probably.
No, it is flag data, but you are inputting for the checking the input for plot image.
Plot
not
image,
flag
yeah.
data.
Go tget flag data or default flag data. Sorry. Default.
Just default flag data
You are-
and enter the input.
it is already there. You can clearly see just tab. Yeah. Okay. Hmm? It is base saved parameter. This parameter will be saved.
Where will it? Where will it save like?
So there is this flag CMD table or to a file that would be saved. So you can do it or you cannot. It's up to you. And this is basically you are giving a reason. Like so basically you are flagging something to keep track. Let's say after 1 month you again start working on that. You will probably forget why are you doing this. So you can open this table or the
How can I open it?
is that any flag CMD?
Flag version.
Yeah, I think within that there would be this one, the flag CMD one, or flag CMD is let's see. Yeah, there would be that. But it is it's basic. Like you never open those things. It is like for your bookkeeping or not. I never do this thing. But you can do it. So it's basically saying that this is the reason you are flagging this thing. Later on, you probably may check. And that table is basically here, and that table will keep all the information you are providing there regarding flagging. Okay. না এটা বোঝা খুব মুশকিল হবে রাইট তুমি জাস্ট 10 সেকেন্ড ফ্ল্যাগ করছো মানে তোমার ধরো এই একটা স্ক্যান রয়েছে এটা ধরো 5 মিনিট দেন ইউ সি দ্য টার্গেট ফর 10 মিনিটস রাইট তুমি জাস্ট এর একটা ছোট্ট চাঙ্ক তুমি একটা মানে জাস্ট ফর দ্য আই ডোন্ট নো ওয়েদার ইট উড বি জিরো it would be difficult. The 10 second is very small. So you are basically flagging very tiny chunk in the beginning. Okay. No, it will flag all the scan for all the scan. it could be that this, like if you do list of এটা কোথায় তোমার লগরটা ব্যবহার করতে হয়। So check 33147 648 to 650 মানে 10 মিনিট কিন্তু এখানে 21 to 38 মানে অলমোস্ট 17 মিনিট। তো এটা অলরেডি বেশি দেখা হয়, তার জন্য উইথটা বড়। কতক্ষণ দেখো তুমি, ইউ ক্যান অ্যাকচুয়ালি ক্যালকুলেট হাউ মাচ টাইম ইউ অবজার্ভ। Okay, so
The CMD reason or the command reason that's put in, that's simply for your own convenience. You won't be able to read it via CASA. But after every task is run, all the inputs that the task is run with is already entered in the logger. So there's a log file created, right? Every time you open CASA, a new log file is created, and in that log file, every single task with all its inputs that you have run is stored there. So like if you want to find out what the bad or dead antennas were for a particular observation 10 years ago, you can, if you have put in the command reason, you can just open the log file, control F for the bad antenna or whatever command you would have put, and you can basically just see like whatever the dead antennas were, whatever the bad channels were, and so on. You can read through log like all those things that you're inputting right now. So you won't actually, like CASA won't actually use it. It's for you, the user.
okay, so next, do the next one. So you are flagging right now the first 10 seconds of every scan. Now you flag the last 10 seconds of every scan, okay? Which is also unstable because your dish is again moving away from your calibrator. So the task is basically same. You change the quack mode to NB. So everything is same. You have quack, you are flagging 10 seconds, but the mode is basically NB. NB is basically you are flagging the last 10 seconds. Okay. So just change that and then again run go. So it will just basically flag the last 10 seconds. So there is only one change, which is the quack mode, nothing else. Everything is same. Okay. So which is basically this region, this one. And rest of the tasks are same. If you are already here, you can then just run go, it will flag the rest. Like as otherwise mentioning, you can always open the logger and check whether it is working or not. You can clearly see that it flagged the percentage of data, which is basically 1.21% using that task. So it's basically flagging a very tiny amount, like 10 seconds of every scan in the logger file is basically showing the same statistics, like how much data you are flagging. It is like 1.21%. So it's a really small amount of data you are throwing away. I also forgot. Let me ask. Maybe your flag is basically stored in the flag manager. Can, where is there Google or something? This one is Firefox. Forgot that how to get the data back. Do you remember the task how to get the data back? Like she flagged 90%. Instead of NP, she flagged the interscan. This is stored in the flag manager, right? But how to get that? Flag manager. Yeah, it flagged actually 90%, 98%. That is already stored there, right? To go do ls. Do ls. No, there is a separate ms file. Do ls. No, there is a restore.
This would be the most recent one, right?
Yeah.
This one. So,
Not deleted, restore. You want to restore that flag, right?
no, the flag version would be deleted. Restore means if you have like unflagged something, it will restore the flags on it.
Check the plot ms whether it is actually data is there or not.
You can check the logger also. Open the logger. Flag manager. Yeah, you can plot.
Plot may check the you are plotting everything. Wait, it's coming. Probably. Oh, you are running the cluster, right? It's taking time to come. I think old 1.8. This is the file, right? Space. Okay. 28. Then iteration over at the iteration. Ether axis, sorry. This is a small amount of error. Let's see. Already flagged. I told him it's not delete, it should be restore. Like restore means that you're restoring the flag. Wait. Let me ask him. Atharva? Yeah, leave them. They have already Samit, right? You come here. Come on, man. You guys will figure out in Indore. See, this is not coming back. It is already deleted. This 90% still flag, right? I thought this would be restore, not the delete in the flag manager. Okay. And
You can start from the beginning. You will reach here by 5 minutes. All the instructions
Yeah.
are already there in the document. So you can always restart this.
yeah,
Sorry, but
that option should be restored, I guess, because it will be restoring the last flag, which is the flag data 4. So flag data 4 mein she actually deleted 90% of data. I think if you put restore, then that 90% data will come back, and then she need to run again the quack mode. But nevertheless, you just delete the MS file and start in the beginning.
delete the MS file and its flag versions also.
Exit casa ls you have you. So this flag version is yeah. So you flag image and bought the flag version also, just because flag version is have all the information. So you flag both of these. This would be minus RA because these are directories. And then you enter it and do the follow just first few steps. You should be done. Yeah, that MS file and then not this one. The one you are actually working with. Let me send 1% to you. Abhirup. तुम थोड़ा सा इधर बैठ के देखो क्योंकि she had to start from the beginning again because she flagged 90% of data. But she's starting from again. Just sit here and check whether she can come up to here this point. Okay. थोड़ा सा एक yeah, go slowly. There is no need to hurry. Like we are almost done in flagging. Like we have only one task left, and then we will do the calibration. Yeah, he's here. I think he will. तुम थोड़ा सा इधर बैठ के देख लो. What happened? What is the issue? There is no issue. I'm just trying. Oh, you are plotting the flag one. Okay, let's move to the last flagging, which is TF crop. I hope everyone has flagged beginning and end and bad antennas and bad channels. So the last flagging is basically where I'm. Is basically this task called TF crop, which is basically time frequency crop. Okay. So the algorithm is a little bit difficult, but you can just look into the algorithm later on. So what it will do is for every baseline, I think it will go to a time frequency plane. Then they run a MAT filter there. And if there is any outlier using this time cutoff is 6 sigma, frequency cutoff is 6 sigma, they will flag all those brightest outlier in your data. Am I right? Yeah. So we are basically throwing away the huge outlier which is present in your data using this TF crop task. Okay.
So usually TF crop is a little risky to run blindly. So you need to like be aware of what your data is enough to kind of run that particular task. In fact, the task has a mode called calculate, which you will do first. Okay, so when you calculate, it will basically analyze the data and estimate what fraction of the data will be flagged if you run the task with those particular input parameters. So the action there, calculate, that will basically just give you an estimate of the flagging. And then if you change the action to apply, it will basically apply the flags on to those extreme outliers. Sometimes the data can be like really good and you can basically lower the cutoffs. Sometimes the data can be really bad and you will have to raise the cutoffs. So it's always better to first calculate and estimate what chunk of your data will be gone if you apply this. So we have these are with this on this particular data you can directly use these parameters. But if you are using your own data, you need to be little careful with it.
So it's basically like, as he mentioned, two-stage flagging. One is you calculate, you find out whether your estimate is okay or not, and the next step is basically you flag that data. And some experienced people will just do the flagging in the beginning. So, but for your purpose, you can check it. So start with default flag data, then do INP. First put the V's, which is the data you are working with. Then mode is TF crop, and then do INP. So you can now see a lot of options within the TF crop. Okay. So then follow what are the parameters we mentioned. So spectral window should be, there is no spectral window we are mentioning. End time is scan. Then do again INP. You can see that you are basically putting everything in a kind of, so end time is span. So for each chunk, they will take the entire scan. Okay. Then time cutoff is 6.0. Frequency cutoff is 6.0. So you can clearly see that I mentioned. So it's basically throwing away all the data point which is 6 sigma outlier, and in the frequency it is 6 sigma outlier. Okay.
So this will basically estimate it scan by scan. So in each scan, it will do like 6 sigma estimation, and whatever is beyond that, it will tell you to flag. This is simply because you're going scan by scan, because otherwise the flux calibrator amplitude is naturally very high. So the sigma value for all scans combined doesn't make any sense. So you go scan by scan only.
Okay, so initially we will do the extend flags false. We will come to that why this is so. And then the last option is we do not apply in the beginning, we do action equals to calculate. And then display is both. So this is what the task looks like. So you provide TF crop, which is the mode of operation, how you are basically flagging the data. You provide time cutoff, frequency cutoff is 6, basically throwing away 6 sigma outliers in your data. It works scan by scan, as he mentioned. you do not extend your flag initially, so that is why it is false. Then action is calculate, display is both. Okay. So first it will calculate and display in your time frequency plane what you are actually flagging. So I hope you guys are able to provide these options. So it's basically, this is the algorithm we are using. So the fitting function is you have the data. For each data, you have a time and frequency plane, and you fit something. So along the time, you are fitting line, and along the frequency, you are fitting polynomial. And then in that fit, so if you will have some outlier, right? And that outlier would be if there is a 6 sigma outlier, that is fit. You can change time to like line to poly or poly to line, whatever if you're comfortable with. But this is particularly for this data. Sometimes you need to change those things. Okay. So if you have a time frequency data, they run a smoothing filter like a matte filter. You go like this, and then as a time and frequency, they fit this thing, okay, line and polynomial. And so if you have a data, you have a fit, you have some 6 sigma outlier, that 6 sigma data points will be flagged. For GMRT, if you have very bad data, you need to reduce that cutoff, let's say 4 sigma, 5 sigma. But this is before calibration. So before calibration, we are just flagging extreme outliers. That's all we are doing. After calibration, you would expect that all your data would be like a smooth, right? Like a flux calibrator would be just smooth. Then the idea is if you have a smooth one, but if some data points are 5 sigma outlier, you are flagging 5 sigma. So then you can play with all these parameters. But for this data, this is very clean data. It is pretty easy to do this thing. It's not coming. There should be a time frequency plane data. Why is not coming? Are you getting same thing? No. Oh, okay. Because yeah, like you will get something like this. So you can clearly see that this range you already flagged, right? This is blue.
Like frequencies.
And you also flagged the initial range. You also flagged some initial time, right? So that's why this is coming. This is 33147 one scan. Okay. And you also flagged the end range by the quack mode.
This is flag.
The blue one is flagged. Now, if you just go to like, you can now play around next baseline or fix antenna, something like. There are a lot of options. Next scan, next field. You can go to like this. Oh, sorry. Like let's say, like you can find that there is 2 points which are like there are outliers. They are flagging these two. So this is another flagging. This is a new flag. This is already you flagged before, right? You flagged the end channel. You flagged the beginning channel.
Starting time.
Yeah,
ending.
end time. End time is very small, I guess. So you can now look into like, this is fine. Like this is not over flagging everything. You are just flagging the this antenna is probably flagged. C is or it is already flagged. So this is a good way to check which one is there. Now this is next baseline. You can now do next scan probably. Okay, so this is now in, no, this is in phase calibrator, 053 phase calibrator, and the next scan is it's coming up. Okay, no, it's fine. Yeah, this is the target. It's now I am already again the next caliber. So you can now check with all these things. You just need to find out that if it's not flagging everything, you have some little flagging here and there. So this is what is going on. And this is already done. You already flagged the bad antenna. Yeah. So you are now in the TF crop. Why you want to do go? Yes.
00 and 01 baseline. Like, why is it that?
No, I think it's not black. I think it's the flux of this particular baseline is low. Probably this baseline is bad. Okay. This is
00 and 01.
yeah. XPW0. This is scan 5. This is RR polarization, right?
This is one baseline, right? 00 and
01.
But what is this after? This row is what?
Well, this is R. This is LL. This is
This row is after like.
no, it is basically pre-flag means you already have 29% data flag. With this task, it will flag 0.1% more. Okay, I think this is the plot. I think they squeeze a color bar here, right? Like, let's see. Here, this is the outlier. Here, this is the outlier, and this outlier is being flagged here.
Oh, okay.
Okay, so this is like there is no color bar. It's bad plotting. Now, nevertheless, what it's basically saying is that in the time frequency plane, you have this outlier which has very huge flux. So in the 6 sigma cutoff, this range is being identified and this is being flagged here. So this is the final plot you are getting, which is fine. You can clearly see that this is already like in comparison with the background, it is way out, way above, like the contrast is way above. So it's basically flagging very few. Like the pre-flag 36.1, now you are flagging another 0.5%. You can clearly see again, this is very bright and it is actually flagging. So this is a way to check. But why this is Mac? Abhirup, in this TF crop, in the Mac, the 2D image is not coming. This is Mac, the 2D image of the TF crop that is not coming. Like all the Linux machines, it is coming. I don't know why it is not. Problem?
Display is working now. Logger is coming. So it should work.
Yeah, logger is coming. Yeah, it is like the algorithm is a little bit complicated. It's basically go to each baseline or each antenna and you go to one scan. Okay. Then you plot it as a function of time and frequency. Okay. And then in the time frequency plane, they are trying to find a bright outlier in the time frequency plane. How to do that? Then they use this time and frequency field, which is line fit along the time, frequency fit along the polynomial. They have a window, and if there any point which is 6 sigma outlier of that in that fit, you flag it. So basically, if you give n, it's basically if you have some data point like this, you fit something. But if you have a 6 sigma outlier here, they are flagging that point. So you can just now then play with that. So why is it 100% flag? Close it and INT. It should not flag 100%. More.
feats, extend falls, calculate, display both.
See, this range you already flagged before, right? The end channel. This is the beginning channel, and you flag some end scan and beginning scan and end scan by quack mode. So that's why those are blue. This is the actual plot, and then this is showing which time frequency chunk will be flagged. You can clearly see that it is flagging very less. So previously you have for this particular baseline, for this particular scan, you have 32% flagging. Here they are flagging very less, like this 2 pixel here. Here also very less. So I think combined would be like another 0.4% data will be flagged. Okay. So now you can play around with this. You can go to next baseline. Here it is flagging this range. This is before flagging, this is after. What is it? So when you go now action run or basically apply, they will just apply this. It is very, you now go to next scan. This is phase calibrator. Let's go to target. Like ideally, like you cannot see those flags by okay, here you can clearly see that. So they found out that this range is very bright in the target, and they actually flagging this thing which is blue here. Okay, and it is showing that 29% previously flagged, but now with this new task, it will flag another 0.4. And you can clearly see that in this data, in this particular frame, like time frequency plot, you clearly see these are like outliers, right? You can clearly see that. So now you can just, play around with this just to check what it is flagging. It is hard to see here because this is a bright calibrator, but in the target, it is easier to see. So you cannot do it by eye. What you are doing is you are running this algorithm, you are finding those samples, and just like now we should apply, right? And get it done. कैलिब्रेशन तो हो जाना चाहिए. कैलिब्रेशन तो जस्ट रन कर देंगे, राइट? कर देंगे बट
बताने के लिए.
Right. Okay, I hope you guys have already looked into this 2D plane and calculate and check what it is flagging. Now we are just applying that flag, okay? So change action to apply. And remove the display one.
So
Okay.
turn off the displays, change the action to apply, and go.
Yeah, so this is the main thing. Like I change this thing, apply. So if in first stage you just check what it is flagging, and the next step you are just applying that flag. That's all you are doing. So if you are at this stage, just run go. E. You have Mac, na? Yeah, you can just check that display. Right, go. You check. You already wrote right this. Okay. You guys should have already checked. Now you can again do the display and check. Calculate. Display both. In display both. INP. Now go. Already I asked. Now you এটা বড় করো. এটা বড় করো. So it's basically you guys already flagged the end channels, so blue, beginning channel blue. You also flagged the beginning of the scan, blue. There's a tiny line at the end, is also flagged. So this is hard to see, this like flux caliber, it is really bright. They are basically flagging very small amount, like 1 or 2 pixel here in the time frequency, this pixel and this is blue. So this is before flagging.
Okay.
And when you run that TF algorithm, they are finding these 2 pixels which are bad, and this is very tiny amount, like 32.0 to 32.4%. So previous flagging is for this particular baseline, for particular target, for this particular scan, you flag this much data, and if you run the TF crop, do an action apply, they will flag 0.4% more. Then you can go to next scan, or probably like there are a lot of options. You can browse through next baseline, next baseline. There are 435, it is painful. You can go to next scan also. Okay, it's coming. So now this is phase calibrator. This is also like they found that this region is bad. They are flagging this region. Yeah, like it is hard to see here, but in that algorithm, they are finding that these 2 pixels are bad. You should be careful that if it is showing that all these things are being, they are flagging with your, then you need to recheck like whether your parameters are okay or not.
Time frequency cutoff.
Yeah, time frequency cutoff, you can probably increase, decrease, whatever. Not decrease, probably increase.
এইটা একদম ছিল না না বলো ডিসপ্লেটা
No, no.
ছিল ডিসপ্লে বদলে চালাই
So scan is basically, scan you already checked, right? You have this, in the list of, you first observe the flux calibrator, right? So it is scan 1. Okay. Then you go to the phase calibrator whose flux is probably this. This is number scan 2. Then you have target. It is number scan 3. Then again phase scan 4. It is basically the number. So you go to first phase flux calibrator, scan 1, scan 2, 3, 4, 5. You can clearly check this thing.
If you are like done with this TF crop and you have applied the flags, we can go on to the next phase. So everyone, if you want to examine, you can examine it at your own time, but like we should
Let's say.
move ahead with the
But you do not
calibration.
have one sample here, right? You are basically divided this 10 minute by, let's say, 120 second. So how many sample you will have? So within this 10-minute window, you have, let's say, 100 samples. So this is your integration time. So you are basically observing for 10 minutes, but for each 10 second or 120 second, you are having one sample. That is your integration. You are integrating and you have one time sample, one data point. So you will have, yeah. So you are basically, let's say, 2 minutes your integration time. So you will have 5 samples here. 1, 2, 3, 4, 5. So now if you have a 2 second, then you will have 50 samples. Yeah, it is your average time. So you are observing a particular source for 10 minutes, and integration time is up for every 10 seconds you are averaging and put one data point, then one data point. You cannot ever take a one long shot, or you cannot take a very small resolution, right? This is your time resolution. So every 10 seconds you have one data point for that 10 minutes scan. You will have more data points. More data. Yeah. Yeah. And see, this is very interesting version. So this is your target. You can clearly see, let's forget about this. You clearly see that these time frequency chunks are very bad, right? It is way higher. So when they run this algorithm, they find that this is 6 sigma outlier. They are just basically flagging those range. You see that this is blue means this flag will be applied here. It is basically showing you what you are flagging. And you can also see that previously you have 29% flag. After this flag, you will throw away another 1%, roughly 0.9% of data.
How do you figure out this frequency?
That is the algorithm presented all within the TF crop. They basically go to this plane.
Take small chunks, estimate the statistics in there, and then based on that, whatever is outside 6 sigma.
Yeah, so I think the idea is very simple. Like what he mentioned, you have a small chunk of data, and let's say you have this kind of data, and you kind of, let's say, feed something here. But let's say you have a data point here that is 6 sigma outlier. Like this is one data point like this. So you find out, okay, this is outlier, flag it. like details of algorithm, it is not possible to cover now, but you can look into CASA. They have mentioned all the
For
details.
now, just apply it because we need to move it.
Yeah, now then go to app.
Plotting this amplitude more data points in the lower frequency.
Yeah, just put the flux calibrator. There are a lot of calibrators, right? And you are flagging, you are plotting all the fields. Yeah.
Number of
Yeah, probably some calibrator is giving you some particular field is giving you this large deviation, but we are calibrating based on flux calibrator, right? So you check the flux calibrator.
You will calibrate based on flux calibrator. You are also tagging based on scan by scan. For now, just you have applied the TF prop, right?
Yeah.
Okay, so we can move ahead with calibration.
So these all these things will be resolved after calibration. So it is not calibrated, right? It is like random one.
So I hope you have all applied the flags because we are moving on to calibration. If you want to check out more details or how TF crop actually works and everything, you can just Google CASA documentation and you can find out all the details over there. But due to time constraint, we have to move on.
Okay, so I hope everyone attended last day's Nirupam's talk. He mentioned this equation, right? If you guys remember. So we are just going to find out this one, which is bandpass calibration. We are also trying to find out the gain calibration. When we find out, we will just divide that out. That will CASA will do, and you will get back the true visibility. That is the plan of calibration, right? And I also divided this gain into amplitude and phase. Like it is a complex quantity. That's why I divided into amplitude and phase. And there is no star because I write the complex part here. Okay. And this is your bandpass calibration. So this is what we are going to do. Before bandpass calibration and before this gain calibration, we have one step, which is a delay calibration. So yeah. So first task is obviously if you open the go to the calibration task, you are basically setting the flux of the known calibrator. That is also Nirupam mentioned, right? You know some calibrator which are very well measured and well monitored over the years, and you are basically setting a model based on that, right?
So there are 3 to 4 calibrators usually GMRT uses. So in this particular observation, the flux calibrator 3C147 was observed as flux calibrator. So in CASA, there are already pre-saved models for this calibrators. So what you do is you basically just tell the model that regardless of what is observed, set the flux of the flux calibrator to the actual like real flux which it should have, and then by step you will apply this calibration from flux calibrator to onto phase calibrator and from phase calibrator onto your target. So you will go step by step and you will interpolate in between.
Okay. So first task is basically setting your model, and that task is set Jansky. And you can clearly see that they are taking from Parley Barnard 2017. This is a paper. You can all of you can just look into that paper later on. So all the models are taken from that particular paper, and it is already stored in CASA. You don't need to do anything. You just mention your visibility, which is your target field or your target MS, like the MS file you are working with. And then in the field, you guys remember, right? What is your flux calibrator? It is 3C147. Okay. Which you can also check by list of if you forgot, but that is fine. So all you need to do mention these two. One is your visibility file, which is your .ms file, and your field is 3C147. And they will just take the model and you have a name model column in your data file based on 3C147. I'll show the model column also after that. So if you are already at this stage, just run go. You can also check this also in the document. It is also mentioned here. Okay. So if you are not following this one, you can go back to the document and check it.
I have a question. Can you explain the ninth step again in the document, in the PDF,
Hmm?
where we extend the flags, like grow time means?
We have not extended the, okay.
Yeah, so I'm, yeah.
Okay, so before going there, we should also do this task. So this is basically saying that you are flagging some chunk of your data, but if for a particular scan it is flagging 80% of data, you flag the entire scan. So something like that. Okay, so it is basically growing the flag. That is all it is doing. So keeping 80% flag data in your actual data doesn't make sense. If you are already flagging 80%, you should flag the rest of the thing. So that is why it is mentioned that you extend your flag if something is 80% already being flagged in your time frequency plane. So okay, you guys are already there. Okay. I have not flagged it, right? I should flag it first. Let's see whether people are already here or not. So I hope everyone is now extending your flag, basically saying that if you have 80% flag in some particular time frequency range, you just flag the entire range. And if you are already here, you just run go. So I hope everyone finished the extending your flag and of the TF top. And now let's go to the Sergensky. So now we are setting the model using the Sergensky task. Yeah. Yeah. So we flag most of our bad data, not most, like most of our bad data which already they have found. And now we are going to start the calibration. So in the starting of the calibration, you need a model, right? That is what Nirupam mentioned yesterday. So you are basically taking that model from this Parley Butler 2017 is a paper you can look into later. You take that model and you are just setting your model column on in your data set by using this task, which is Sergensky. Okay. So if you are already here, just run go. And then you can actually look into your in your logger that it is actually putting 21.484 Jansky for Stokesai for this particular calibrator. Okay. So it's like close to 22 Jansky. And you can also check in the plot MS task whether it is already doing that task or not. So I am plotting UV wave plus its amplitude. I'll come to that. Like I will explain why it is. And why data column is basically model. And your field is basically 0. So you are taking that MS file after Serjansky, you are plotting UV wave like your baseline as a function in x-axis, your amplitude in y-axis, and you are plotting the model column. Since you run already a Serjansky task, you should have a model column now. And this is basically checking that thing. And you are also keeping field 0 because you are setting the model of the flux calibrator which has field ID 0. Okay. So if you are already here, you can also reduce the data volume by averaging time and frequency. So average time. So I am averaging all the times and I am also averaging all the channels. You have 256 channels.
So
So
this averaging is working only within, like, for plotting purposes. This is not actually averaging anything within the data.
Yeah, this is just for plotting, just to reduce the RAM requirement. Okay, since you are working in your laptop, you just average time is 188, you average everything every time. And average channel is 256 channels. We know that you have 256 channels, you are averaging 256 channels. So if you now do this, so you can actually change the axis range. Okay. So you are changing the y-axis range like that so that the plot will look nice. So you have a model which is like close to 22 Jansky or something. Yeah. Right. So you should remember that this is just a point source in the sky. So it's UV. Sorry, its UV response would be just flat, right? This is just a Fourier theorem. If you have a point source in the sky, its Fourier transform would be just as a function of baseline, just a flat. And that is what you are getting here. No, I am averaging all the channels. Yeah, so I am basically averaging all the channels and all the time, just to reduce the RAM requirement. That's all. But it is actually not averaging the data. It is just for plotting. Okay, you can just plot it, and this should be true, like, because you are just taking some published data set and you are setting that model for that. So we are basically calibrating against this model. So you have a model, you are basically calibrating against that. Another plot which you can do. Yeah, go ahead. Have you done Sergeant's? Then I'm just plotting the model data column. X-axis is UV wave. UV wave is your baseline. So yeah. Yeah, so you are plotting the x-axis is UV wave. It is basically baseline divided by your wavelength of your data, okay? Like the frequency you're working on. And in the y-axis, I'm plotting amplitude, and y data column is model. So you already set a model data column, you are just plotting that. And I am also averaging over time, also averaging over channels. So this is coming later. So I am averaging over 256 channels, I am averaging over all the times, 188. And I am also providing the field which is 0 because we are setting the flux calibrator model. So flux calibrator is 0. So that's why I'm plotting the flux calibrator. So this can be done in your laptop. It will require very less amount of RAM. Right? That's why I'm averaging those things. Just within plots. Yeah, just within plots. Flag data. Oh, have you not done the extend flag? You guys want to know this thing? you guys done TF crop, you apply the TF crop, and here we are just extending, saying that if 80% of data flag for some chunk, you flag the entire chunk. That is what we are doing. Averaging. This is plotting purpose. So if you have a large RAM, you can plot everything. But since you are working in a laptop, we are just averaging to reduce the RAM requirement. Yeah, you can also plot. Yeah, another plot I should ask you to do is basically plot like this. You plot UV wave versus, so you are plotting the model data color as a function of UV wave. You can also plot it as a function of frequency. You choose frequency and you remove the average over channel. Otherwise, it will give a 1 point. So you are just plotting the model as a function of frequency. You would expect that it would be like synchronous, right? Some power law kind of thing. Because 33286 is a bright quasar, it should be a synchronous. You are getting this thing. So you will basically calibrate based on this model. You have a frequency response which you know from some paper, and you have a data point. So you have a model data, you have a data, you just calibrate based on that. It's a simple case. Yeah. Yeah, it is not log law. No, it's yeah. There is a spectral index, right? So yeah,
It's not exactly straight, right? But like if you plot log, then it will be exact straight line, but this is not exact straight line. It has a curve that's probably not visible.
yeah. You are just plotting like
Because it's a well-known spectral index. So
basically f0 nu to the power minus alpha. You are plotting like this. This is the one you are plotting. Yeah, nevertheless, this model should be correct from the Parley-Butler paper. So Narendra, should we take a break now? It's already 11. So this is 11. Should we take a break now or like 3 calibration tasks? Delay, band pass, gain. Okay. So we have only 3 steps left for calibration. One is delay, one is band pass, another one is gain. And we'll try to do it today. But it is good that everyone is doing. That is good.
Everybody has done Serjansky. Any warrior who could not go up to Serjansky? Died multiple times before that? You are the one, okay.
Yeah, maybe take a break for some time now, and then we'll come back. The people who have already done it, you can take a break for half an hour and come back at 11:30.